Well, we're marching along, graphing rational functions, determining vertical and horizontal asymptotes and intercepts, and then stating the domain of the function. And in these two examples we're going to be looking at where the highest power of the variable x in the numerator is equal to the highest power of the variable x in the denominator, and getting an idea of what the characteristics are of a graph such as this. And so here we've got our first example, and this is corresponding to example 3 on page 134. This is guided practice 3a, where we have a function h of x is equal to x minus 6 divided by the function x plus 2. And so let's start with vertical and vertical asymptotes as well as the domain, and I don't see any common factors in the numerator and the denominator that might create a hole, which we again will cover later. I keep promising that, but we will do it. And so I'm looking here at the denominator. I'm going to go ahead then and determine what the vertical asymptote is, as well as the restriction in the domain. I'm going to set that denominator x plus 2 equal to 0. And we're going to solve for x, which of course x then is equal to negative 2. And that's going to be the statement of my vertical asymptote, where x, vertical asymptote at x equals negative 2. And while I'm at it, I might as well go ahead and address the domain. And the domain is going to be equal to x such that x is not equal to negative 2, but otherwise x is an element of all real numbers. All right, horizontal asymptotes. Now, of course, I go to my horizontal asymptote rule, which states that if the highest power of the numerator is equal to the highest power of the denominator, which is what I see right here. I got x to the first power over x to the first power, and even though I don't see a 1 there, I can assume that a 1 exists. And so my ratio, this is how I determine the horizontal asymptote, is I take the ratio of those powers in the numerator and the denominator. I don't have to worry about any of this over here, at least for now, as it pertains to horizontal asymptotes. And I can say that I've got a horizontal asymptote, 1 over 1 is 1, at y equals 1. Okay, we're looking pretty good so far. Now, how about x and y intercepts? Well, if I'm going to find the x intercept, I'm going to set y equal to 0. Let's change the color of this. I got y equal to 0. And so I've got x minus 6 over x minus 2. Well, if y is 0, when I multiply both sides of this equation by x minus 2, to be solving for x, well, 0 times x minus 2, of course, is just equal to 0. And so I got x minus 6. Well, I should have, if I'm going to isolate the x, I'm going to add 6 to both sides, and so I should have a x-intercept at where x equals 6. That's my x-intercept. And what about my y-intercept? Well, if my y-intercept, I'm going to set all my x's to 0. So I've got y equals, and we'll substitute 0 in for x in the numerator. So I got 0 minus 6. And in my denominator, I'm going to have 0 minus 2. Well, that's going to equal negative 6 over negative 2, which then y is going to equal, I'll divide negative 6 by negative 2. Oh, plus 2, excuse me. Plus 2. reading that wrong. I hit it with my other marker. I should have a y-intercept at -3, so I'm thinking I'm going to have a y-intercept at y equals -3. Okay, I've done everything. Let's see, I stated the domain. I figured the vertical asymptote to be at x at -2. Horizontal asymptote is y equal 1. I've got an x-intercept at 6, should be, and a y-intercept at -3. Let's head to the graph, see what we got. Okay, well, here we are at the calculator. I went ahead and have entered in our rational function that we're looking at. So we got x minus 6 over the function x plus 2. And we're anticipating we're going to see a vertical asymptote at -2 and a horizontal asymptote at 1, as well as an x-intercept at 6 and a y-intercept at -3. Let's jump over here and see what this looks like. And so here we are. We got our rational function, and let's see, right here, x -2. It does appear I probably got a vertical asymptote right there. And let's see, we were expecting a horizontal asymptote at 1, y equal 1. And so just kind of tracing along here, I can see this is across the x-axis right here, so that looks good. Let's see, what about a y-intercept? Well, I see one right there at -3, -1, -2, -3. And we're also looking for an x-intercept at 6. Let's see, 1, 2, 3, 4, 5, 6. Yep, that looks good. Let's check our table. Okay, right there at -2, I see it's undefined. So there's my vertical asymptote. There is my y-intercept at -3. And let's scroll down right here, and I should be able to see my x-intercept at 6. Yep, when x is 0, y is 6. Everything looks pretty good here. I think we got it. We calculated it right, and our graph bears us out. We're in good shape. Okay, let's take a gander at this function where we've got h of x equals x squared minus 4 and 5x squared minus 5. And again, we're looking to find vertical and horizontal asymptotes, intercepts, x and y intercepts, as well as state the domain. And let's see, I'm going to look at this numerator, x squared minus 4. I could actually factor that, and I probably want to get in the habit of thinking about that because pretty soon we're going to be looking at wholes. So let me factor that. So that could be x plus 2, x minus 2, factoring the numerator. And let's see, we're going to go ahead and factor the denominator here as well. Now, I've got a 5x squared minus 5, so I can factor out a 5 right off the bat. And that's going to give me x squared minus 1. And then I'm going to set this x squared minus 1 equal to 0. And solve for x. And so I've got x squared equals 1. And if I want to get rid of the x squared, I can take the square root of both sides, and that's going to leave me with x equals plus or minus the square root of 1. Well, the square root of 1 is 1, and so that's going to be plus or minus 1. Now, that's giving me both the vertical asymptotes as well as the domain restriction. Let's go ahead and see if we can't just write the domain. I'm going to say the domain is equal to x such that x does not equal -1 or 1. But other than that, x is an element of all real numbers. And my vertical asymptotes then are going to be defined as vertical asymptotes at x, x equal -1 and x equal 1. All right, now what about my horizontal asymptotes? Well, I see that my powers here, I got x squared and I got x squared. They're the same, they're equal. And so I'm looking at the ratio of the lead coefficients. And even though I don't see a 1 in front of this x squared in the numerator, there is 1. And so I'm going to have a horizontal asymptote. My ratio is 1 over 5 at y equals 1/5. So I should have a horizontal asymptote at that point. Okay, let's determine x and y intercepts. So what do we want to do first? Let's do the x intercepts first. So I set y equal to 0. Well, so we're going to say 0 equals x squared minus 4 over 5x squared minus 5. Again, I'm going to multiply both sides of that equation by 5x squared minus 5. That's going to equal 0. And so 0 equals x squared minus 4. Now, I'm going to add 4 to both sides. So that's going to leave me with 4 equals x squared. And let's see, I can take the square root of both sides. That's going to leave me the square root of 4 plus or minus the square root of 4 equals x. And so I'm looking at x intercepts at plus or minus 2. So I should have 2 x intercepts. So I should have an x intercept at -2 and +2. All right, what about the y-intercepts? Y-intercepts, I'm going to set all the x's equal to 0. Okay, so we got y equals, change that to 0 squared minus 4 over 0 squared, 5 times 0 squared minus 5. Well, that's all. This is going to just cancel out. It's going to leave me with y equals -4 over -5. And that should tell me that I should have a y-intercept at 4/5 because those negatives are going to cancel out. So let's see what we got here. We're looking for a vertical asymptote at -1 and 1. We're expecting a horizontal asymptote at 1/5. We should see x-intercepts at both -2 and 2. And we should have a y-intercept at 4/5. Let's go graph this little baby and see what we got. All right, well, moving over to the graph, I see I've got put in my first function, x squared minus 4, and it's being divided by 5x squared minus 5. Let's see if we got our graph, and we'll take a look, see if our calculations seem to be correct. Boom, boom, boom. Okay. All right, let's see. We determined that there should be a vertical asymptote at both -1. Well, there looks like 1 right there. That looks pretty good. And at 1, kind of close right there, but I think that's got it. We said that we would have a horizontal asymptote at about 1/5, I think was what we said. Horizontal asymptote at 1/5. Yeah, this looks like it's crawling above the x-axis right down over here on this side as well as this side. Let's see, we had x and y intercepts at -2. Okay, well that looks like that's probably 1 right there at -2 and +2. Yeah, that looks pretty good right there. We'll check our table and see how that looks. And a y-intercept at 4/5, and yeah, somewhere close right in there. Let's go look. Everything looks pretty good. Let's go in here and look at our table, see what we can determine. All right, well there we can see that we've got a vertical asymptote at -1 because we've got the arrow telling us it's undefined, as well as at 1. I can see that I've got a x-intercept at -2 as well as 2. So everything actually looks like it checks out pretty well. Let's go back. What was that deal about the 1/5? So 0 at 0.8. Well, there's my Y-intercept right there. 4/5, that's 0.8. If I take 5 divided by 4, I'm going to get 0.8. And okay, looks like it all checks out. There we go. Graphing rational functions where the highest power of the numerator equals the power of the denominator. We consider the coefficients in determining what our horizontal asymptote is. Everything else we calculate the same. We're just having so much fun.